In this section, we're going to review how to, 1, expand logarithmic expressions, and 2, condense logarithmic expressions using properties of logarithms. Now, in this section, the 3 main properties of logarithms that you learned was the power rule, the product rule, and the quotient rule. So let's look at each one. So in the power rule, it says this: for any positive base b, and remember your base, when dealing with logarithms, the base has to be positive, and the other thing is that the base cannot be 1. So that's what you see here. So for any positive base b, where the base cannot be 1, and for any positive real number x. So remember, whenever you take the log of a number, that number must be positive. You cannot take the log of a negative number, and you cannot take the log of 0. You saw that in the previous section. So for any positive base b, where the base is positive and the base cannot equal 1, and where x is a positive real number, okay, and any real number, so n can be any real number, so n can be positive, n can be negative, n can be 0, any real number, then the power rule says this: when you take in the log of an expression raised to a power with some base, then you can take that power, that exponent, and write it as a product. So notice you can take the exponent and you can write it as a product. So you can say the exponent times the log of x with base b. All right, so in words, this says the logarithm of a number with an exponent. So the logarithm of a number with an exponent is the product, so notice n times, so it's the product of the exponents. Remember, you see n is the exponent here, of the exponent times the logarithm of that number. Okay? The product rule says this. So same thing about the base. Remember, the base must be positive and the base cannot be 1. And we're dealing with positive real numbers, x and y. So x must be positive, y must be positive. Remember, you cannot take the log of a negative number. You saw that. So for example, if you take the log of, let's say, a -5, you're going to get an error. Okay? So you can only take the log of a positive number. Even the log of 0, you're going to get, the log of 0. Let's try this again. The log of 0. You get an error. All right? You can only take the log of a positive number. So for example, the log of, let's say, 7. All right? So you see you get something. You get a value. Okay. But the log of a product says this. So if you've taken the log of a product, x times y, then, remember in words, you can write this, you can write the log of a product as the sum of the logarithms. So the log of the first factor plus the log of the second factor. So make sure you see how that looks. So the log of a product is the sum of the 2 logs. Okay? And then the quotient rule, so remember, quotient means division, so you see a division here. So the quotient rule says the log of a quotient, so if you're dividing, if you have the log of a fraction, let's say x divided by y, then you can write this, so look at the words, the log of a quotient is the difference. Remember, difference means subtract. So it's the difference of the logarithms. Now remember, whenever you're dealing with subtraction, subtraction is not commutative, so the order matters. So notice the first thing you write here is the log of the numerator. Okay? The log of the numerator. So the numerator goes first, and then you're subtracting the log of the denominator. All right, so the log of y. All right? Okay, so those are the 3 properties that you learned in detail in a previous video. So in this section, though, all we're doing is just basically reviewing how to use those properties of logarithms to expand and condense log expressions. All right, so let's look at some examples. And we're going to come back and we're going to look at these properties. Okay, so number one, well, the direction says this: use properties of logarithms to expand. So if you don't remember what it means to expand, you're going to see what it means in a little while. But to expand the log expression as much as possible. And where possible, evaluate the logarithmic expression without using a calculator. All right, so let's see what all this means. Okay, so look at this. Now, notice, you remember, if there's no base, see there's no base listed, right? Now, it has a base, but I'm saying that you don't see a base. So if there's no base listed, it's understood to be a 10. So remember, this is the common logarithm. So common logarithm is base 10. All right, so you're taking the log of 1,000 times y. So doesn't that imply product? So you're taking the log of a product, and the product is 1,000 times y. So that means then I can expand this using the product rule. And expanding means to go from one logarithm to two or more logarithms. So remember, expanding means to go from one logarithm to two or more logarithms using your properties. All right, so since this is a product, then that means I can write this, now look how it looks, I can write this as, and let me go ahead and make a copy of this first. Okay, so let's go ahead and continue. Now, as long as you know these properties right here, then this is not that difficult. It's fairly simple to deal with. All right, so just remember, expand means to go from one logarithm, so you have one logarithm in each case. Okay, so expand means to go from one logarithm to two or more logarithms. All right, so two or more logarithms using your properties. Okay, so number one, I'm taking the log of a product, and that product here is 1,000 times y. So by using the product rule, so remember the product rule says I can rewrite this as an addition problem. So that's going to be the log of the first factor, so the log of 1,000, plus the log of the second factor, the log of y. So that's where we're at, okay? So that's just using the product rule. So the log of a product is the sum of the two logs. So that's what our statement says. In words, the log of a product is the sum of the logarithms. Now, right here though, so let's look at this part. So it says, where possible, evaluate the logarithm without using a calculator. Now what I mean by that is this. Okay, so look carefully. So you have to recognize whenever it's possible to evaluate a log expression knowing things that you studied. So you see this log of 1,000 right here? The log of 1,000? 1,000 I can write as, let me go ahead and rewrite this. So there'd be the log of, and remember 1,000 is 10 to the third power. Okay? 1,000 is 10 to the third power. All right, now, you learned about the power rule right here, the power rule. So the power rule says I can take the exponent, I can take this right here and write as a product. And that product is going to be the exponent times the log. So what that means then is this right here. I can rewrite this as the exponent times the log. So about 3 times the log of 10. All right, now, let's think about the log of 10. Okay, so the log of 10. Now, one of the things you learned in a previous section was this idea. So I'm going to go ahead and remove this and kind of do this. So one of the things you learned in a previous section was that you can always change an exponential to a logarithm or a logarithm to an exponential. So one of the things you learned was that y equal the log of x base b So y equals the log of x base b is equivalent to, and notice I'm saying this, so you can take the base, so you can always write a logarithm as an exponential. So you can take the base, which is b, and you're going to say b to the y equals x, and we're going to call x the argument. So b to the y equals x. So b to the y, that's a y here, equal x. Okay? Now what that means is this. Okay. So what that means then is this. So I have the log of 10 here, and I'm going to go ahead and ask myself, well, what is that equal to? And it doesn't matter if you use a variable. You could use a little box if you want to, whatever you want to. All right? So we're going to change this log equation to an exponential. To do that, I'm going to say the base. Now remember, if there's no base there, it's understood to be 10. So you see that base right here. That base right here is understood to be 10. So that's a common logarithm. So the base is 10. We're dealing with a common logarithm. All right, so the base raised to this exponent, so 10 to this little box, is equal to the argument. All right, so then you ask yourself, what number goes in that box? Well, 10 to what power is 10? Well, it's 10 to the first, right? So therefore, what that means then is that the log of 10 is 1. The log of 10 is 1. So what that means now is this. So the log of 10 is 1, so that means 3 times 1, which is 3. And so now we have this. The log of 1,000 is 3. So that's 3 plus the log of y, and I cannot simplify the log of y, so there's your answer. So that's what I mean. That's what they mean by where possible evaluate logarithms. And this little part here where you dealt with the log of 1,000, that was in a previous section. So you may not remember dealing with this, but it was in a previous section. And hopefully you do remember and you had enough practice with this. All right, so just remember, when possible, evaluate log expressions without using a calculator. Now, it does say that, right? Well, some students just go ahead and use a calculator. So watch. The log, now we're dealing with common logarithms, so don't make sure you use the right one. So remember, the calculator, your calculator uses 2 log functions, log base 10, so you're dealing with a common logarithm, log, or ln, which is a natural logarithm, that's base e. So remember, this is your common logarithm, base 10. So if you say 1,000, the log of 1,000, just like this, watch what happens. Equal, you get 3. All right, but remember, it did say without using a calculator because we do want you to be able to do some of these without having a calculator do it for you, because the understanding of this stuff here and this stuff here is important. Okay, number 2. All right, so if number 1 was the log of a product, then what is number 2? Number 2 is a log of a quotient, a division, right? So you're doing a division. So since that's a division, then we're going to use this property right here. So we're going to write as a subtraction, as a difference. But remember, when you write as a difference, remember, subtraction is not commutative, so the order matters. So the numerator is the one that's listed first. So this becomes then the natural log, that's how we pronounce this, natural log of the numerator. Well, the numerator is e to the 5th power minus the natural log of 16. All right, now, using the same ideas we did with number 1, it says, now remember, one of the things you got to remember is this. Whenever you're told to expand logarithms as much as possible, that also means this. That also means get rid of that exponent. Rewrite that exponent as a product. So that means using the power rule. Okay, so don't stop here. You've got to know that expanding means I've got to take that exponent and write as a product. So this becomes then 5 times the natural log of e minus the natural log of 16. Okay? All right, now, remember we talked about this right here, the log of 10 to the third, right? Okay. And we talked about the log of 10. We talked about, well, how do I know what the log of 10 is? Well, the log of 10 we can rewrite using exponentials. The same thing here, the natural log of e. So let's think about that, the natural log of v. All right, natural log of v. Okay, so remember, the ln, the natural log, is understood to be base e, right? So if you think about it, we can actually write this as log base e of e, or log of e base e. And if I want to write this as equal a box like I did this one, then I can change this log equation, so that's a log equation now, I can change that log equation to an exponential. To do that, I take the base, which is e, and I raise it to this power. So e to the box, or x, it doesn't matter, you can put x here, equal the argument, which is e. Well, e to what power is itself? Well, e to the first power, right? So that means then that the natural log of e is equal to 1. That's what that means. All right, so if the natural log of e is equal to 1, then that means 5 times 1 minus the natural log of 16. And 5 times 1 is 5, so that's 5 minus the natural log of 16. And hopefully you know that you cannot simplify the natural log of 16, because remember, the natural log has base e. E to no nice number is 16. In fact, if you take the natural log of 16, you get this number here. All right, so it's not a nice number like an integer, like 1 or 2 or 3 or something like that. Just like with number 1, you could have said, remember number 1, we said the log of 1,000. Press equal, we got 3. You could have done the same thing with this one, the natural log of v. Now to do that, you got to be careful. All right, so you press the natural log first, and you want to get e here. To get e, see that e, let me see if I can raise it up right here. That e, to get that e there, to get e to the first power here, you're going to use this e to the x. So here's how you're going to do this. So you're going to say second e to the x, and my exponent is 1, e to the first power. Make sure you close that parentheses, so that parentheses right here closes this one, but then let's go ahead and close this one. And when you do that, you get 1. So the natural log of e is 1. So that's what you saw here. All right, but remember, it did say without using a calculator. All right, number 3. So number three actually involves, if you think about it, number 3 actually involves using all these properties. All right, so, and if you think about number 2 involved 2 of the properties, right? Number 2 involved the power rule and the quotient rule. All right, but let's look at number 3. Now, actually, number 3 does not involve all the properties. Number 3 only involves the first 2, power and product. Okay, so y'all do agree that I'm taking the log of a product, and that product is x to the 8th times y. So according to the product rule, I can write as an addition problem. I can write as a sum of 2 logs. All right, so let's do that. So that becomes the log base b. Now don't forget, make sure you write the base. Don't leave the base off, otherwise it's incorrect. So that base must be this base. So the log of x to the 8th plus the log of base b of y. All right, so that's where we're at. Now remember, the directions said expand as much as possible. expand as much as possible. Well, expanding as much as possible means to make sure that that exponent in every case is 1. Well, that's not in 1 here, that's in 8. So we're going to take this 8 and write as a product. So that's using the power rule. And so therefore this becomes 8 times the log of x base b plus the log of y base b, and that is it. That's all you can do. All right, so that's expanding as much as possible. Just remember, you have to use the power rule to expand as much as possible. So you don't want that exponent there. You want to rewrite that exponent as a product. All right, number 4. So in number 4, you have this problem. All right, don't make it complicated. It's really not complicated. Now this is where you're going to use all of the properties. All right, so notice I'm taking the log of a quotient, and the numerator is a product, right? So don't forget your base is t. All right, so according to my rules, my 3 rules, we're going to use the quotient rule first. So we're going to take the log of this quotient first. So that's going to equal the log base t of the square root of x times y to the 8th minus, so remember the log of a quotient, the numerator and denominator is the difference of the logarithm. So the log of the numerator, see this, log of the numerator, minus the log base t of the denominator. Okay, now remember, expand as much as possible. But if you look at your first log right here, that's the log of a product still. So since that's the log of a product, I can expand it using the product rule. And the product rule says I can write it as a sum. So then this becomes the log base t of the square root of x plus the log base t of y to the 8th power minus the log base t of r to the 4th. All right, so notice the first thing I did was I used the quotient rule to change it to a subtraction. So the log of the numerator minus the log of the denominator. That's what you see here. But then I notice also that first logarithm is a log of a product. And so that means then I can expand it further by using the product rule. So I can change this to a sum. Okay, now remember, let's think about the power rule now. Okay, this one's easy right here. All of you can recognize that when using the power rule for this one, I'm going to say 4 times the log of r. So that one's easy. Okay, so that's going to be 4 log of r base t. Same thing here, right? I can take this 8 and put out in front. So that's going to be 8 times the log of y base t. All right, now let's talk about this though. Okay, so one of the things you learned in this course or in another course is this. Okay, one of the things you learned is this. The square root of x means x to the 1/2. So you can always change a radical expression to an exponent. You can always change a radical to an exponent. So x to the 1/2. So your property, if you remember your property, if you have, let me write it like this, the b root of x to the 8th power. So changing a radical to a rational expression, you're going to say x to the numerator divided by the index. Remember, b is called the index. So it'll be the exponent. I said numerator, I mean the exponent. So x raised to the exponent, which is a, divided by b. So when I look at this, the square root of x, that exponent right here is understood to be a 1. That's just square root, right? So remember, there's no number there. It's understood to be a square root. So that's a 2. So this becomes x to the 1/2. All right, so then, knowing that, and that means I can rewrite this as log base t of x to the 1/2 power plus those two expressions. And then using a power rule in this now, I can write this as 1/2, so the exponent times the log of x. So that becomes 1/2 times the log of x base t plus 8 log times the log of y base t minus 4 times the log of r base t. And that's it. So you've expanded this log expression as much as possible. Okay, number 5. So in number 5, we have, again, the same idea that we've used here. So you have the log of a quotient, and in the numerator, that's a product. So we're going to use the product rule and the quotient rule. I also see an exponent. So since I see an exponent, I know that I'm going to use the power rule as well. So let's use the quotient rule first. So that's going to be the log base 5 of the numerator, okay, minus the log base 5 of the denominator. Okay, so the log of a quotient I can write as a difference of logarithms. So the log of the numerator minus the log of the denominator. Notice again, this is a product, so I'm taking the log of a product. So since I'm taking the log of a product, x times x plus 5, that's a product, I can use the sum, the product rule. So I can write as a sum. So this becomes the log base 5 of x, that first factor, plus the log base 5 of the second factor, x plus 5, minus, and for this one, I'm going to use, remember, you want to expand as much as possible, so I'm going to use the power rule here, so it'll be 3 times the log of 5, so the log of y base 5. So 3 times the log of y base 5. And that's it. That's all you can do. Now, don't make the mistake. Some students make the mistake when they see this right here, they think of the distributive property. Be careful. That's not the distributive property. You're not saying the log times x plus 5. So that's not multiplication here. So be careful. All right, so that's all you can do. All right, number 6. Now, it looks a little bit more complicated, right? But it's not. Let's just think about this. Okay, so notice I have a quotient and I have products, and this time I have a product in the numerator and I have a product in the denominator. I also know that I'm going to use a power rule. So I have a 4 here, and also now know that I can change radicals to rational exponents. All right, so let's go ahead and use the quotient rule first. So that's going to be the log of the natural log of the numerator, so x times e to the 4th, minus the natural log of the denominator, so x times the square root of x minus 3. Okay? Look at the first one now. I can still go further, couldn't I? That's a product right here. So I can use the product rule. So this becomes the natural log of x plus the natural log of e to the 4th. Now be careful here. So you're subtracting. So you're subtracting, and then notice that this is a product still, right? That's a product. So I'm going to change this product to a sum. But I'm subtracting all of this. So put all of that in parentheses. It's important. Whenever you're subtracting, always put, to help yourself not make mistakes, always put that in parentheses. So you're subtracting, and again, you're taking the log of a product, x times the square root of x minus 3. So I am going to use the product rule, which means I can change this to a sum. So this right here, if you cover this up, this means the natural log of x plus the natural log of the square root of x minus 3. Okay? Now let's get rid of the parentheses. So subtracting means adding the opposite. So this becomes the natural log of x plus the natural log of e to the fourth minus the natural log of x, and then minus the natural log of the square root of x minus 3. Okay, now, one of the things I want you to notice, first of all, is that the natural log of x, subtract natural log of x, that's 0, right? So those cancel each other, so the sum there is 0. So really all you're left with is the natural log of e to the fourth minus the natural log of the square root of x minus 3. Now at that point, to expand it further, I'm hoping you recognize that I can use the power rule. Especially with this one, you see an exponent very easily. So it means I can write this as 4 times the natural log of e. Now for that one, here's what you have to do. You have to recognize that the square root of x minus 3, the square root of x minus 3, then write it right here, the square root of x minus 3 is equivalent, the square root of x minus 3 is equivalent to x minus 3 to the 1/2 power. So see this right here, I can write this as, in parentheses, 1, so 1 divided by 2. Okay? And so that's what you're going to write this as, or you need to write this as. So it'll be x minus 3 to the 1/2 power. And now I can use the power rule here, just like it did here. The other thing I want you to remember is that the natural log of e is 1. So that's 4 times 1 minus, and this becomes 1/2 times the natural log of x minus 3. And so therefore the answer is 4 times 1 is 4, so you get 4 minus 1/2 times the natural log of x minus 3. And that's it. All right, so not difficult. Okay, number 7. So another thing I want you to recognize, some of you may say, well, couldn't you just have reduced the x's here? Yeah, you could have. So watch. You could have easily done that. So those are common factors. You could have done that. So this would have been, let me just rewrite it. Okay, so you could have said, well, these divide out, right? And so you get the natural log of e to the fourth divided by the square root of x minus 3. And so then this would be the natural log of e to the fourth minus the natural log of the square root of x minus 3. And then using the power rule, this becomes 4 natural log of e minus, and then remember this right here is x minus 3 to the 1/2 power, using a power rule here. And the fact that this is 1, I get 4 times 1 is 4, so I get 4 minus 1/2 natural log of x minus 3, which is what you had here. Okay? All right, let's look at number 7. So number 7, lots of stuff here, right? Okay. So I'm going to use the quotient rule first. That becomes the log. Remember that there's no base there, so this would be 10, so that's common logarithm. So the log of the numerator, 10 times x to the times the cube root of 3x plus 1 minus the log of the denominator, so minus the log of 3 times 2x minus 1 to the 7th power. Okay, now I want you to notice you're taking the log of 3 things here, of a product of 3 factors. So using the sum, this becomes, using a product rule, this becomes a log of 10 plus the log of x plus the log of the cube root of 3x plus 1. Okay? So the log of a product, just so happens it's a product of 3 things, is the sum of the logs. So the sum of the first factor plus the sum of the second factor. I didn't mean the sum. The sum of the first factor plus the second plus the third. Just like in the previous problem, you're going to be taking the product rule here, but remember that's subtraction, so put that in parentheses. So that becomes a log of 3 plus the log of 2x minus 1 to the 7th power. Then getting rid of the parentheses remember, subtraction means adding the opposite. This right here, or this whole thing becomes, and by the way, the log of 10, remember, is 1, right? 10 to what power is 10? So that's 1. So that's 1 plus the log of x. And right here, I'm going to write this as 3x plus 1 to the 1/3. So just remember, the cube root of 3x plus 1, I'm going to put that in parentheses, raised to the first, is 3x plus 1 to the exponent divided by the base. So that's 1/3. Okay? So then this becomes log of 3x plus 1 to the 1/3. And then getting rid of the parentheses, that becomes minus the log of 3 minus the log of 2x minus 1 to the 7th power. We're not done yet, and the reason we're not done is because of those exponents that you see here. And so then that means I can use the power rule. So this becomes 1 plus the log of x plus 1/3 times the log of 3x plus 1 minus the log of 3 minus 7 times the log, in parentheses, 2x minus 1. And that's all you can do. There are no like terms to combine, and so that's it. That is your answer. Okay? All right. So that's expanding. So now let's look at condensing. So condensing means this. So we're going to look at condense. Some books will instead of use the word condense, they'll say contract. But condense means this. So condense means you go from 2 or more logarithms to a single logarithm. That's what condense means. So condense means going the other way. So in other words, let me go ahead, here we go. In other words, condense means to go from the sum of 2 logarithms to 1 logarithm. The difference of 2 logarithms to 1 logarithm. The product to where the coefficient of the log is 1. All right. So condensing means to go from the right-hand side to the left, the right-hand side to the left, the right-hand side to the left. All right. So let's see how that looks. Okay. So, and also remember, and this is important, that when using these properties right here, when going from the right-hand side to the left, you got to make sure that those bases are identical. Okay, they have to have the same base. In order to use these properties, the bases on both sides have to be identical, and they are here. Well, so notice the base here is understood to be 10. Okay, so then you see how you're taking the log of the sum of a log, right? So based on our properties, that's the product rule. So that means then that I can write the sum of a log as the log of a product. Okay, so that means then I can write this as the log of the product of 25 and 4. Well, what is 25 times 4? Well, 25 times 4 is 100, isn't it? So that's the log of 100. All right, now that's the one where you want to, where possible, evaluate log expressions. So remember, the log of 100 means the same thing as the log of 10 squared. And then using the power rule, this becomes 2 times the log of 10. And remember, the log of 10 is 1. 10 to what power is 10? Well, that's 1. So then this becomes 2 times 1, which is 2. So that means then that this right here, which is the log of 10 squared, which is 2 times the log of 10, is 2 times 1, which is 2. So the answer is 2. Okay, let's look at number 2. So number 2, before you can use the product rule, it is very important that you notice before you can go from the sum of logarithms to a single logarithm, 2 things must occur. You have to have the same base, And the coefficient of those logs have to be 1. The coefficient of those logs have to be 1. Our issue in number 2 is this 6 right here. The coefficient of this log is not a 1, that's a 6. Well, we can easily take care of that. We can easily take care of that by using that product rule right here. So when you have n times the log of a number, then I can take that n and write it as an exponent. So that means then I can take that 6, I can write this as an exponent. So this becomes the log of x plus the log of y to the 6th power. And now the bases are the same. The bases are 10. The coefficient of the log is 1 in both cases. So now I can write this as one logarithm. And since that's a addition here, that single logarithm is the product. So it'll be the log of x times y to the 6th. Okay, and let's just go ahead and put that in parentheses. So the log of x times y to the 6th. And that's it. There's your answer. You wrote it as a single logarithm. So condensing means write as a single logarithm, and whenever possible, evaluate. So even though I wrote as a single logarithm right here, number 1, I can evaluate it further. So that right here is equal to 2. Okay, number 3. So number 3, you have the sum of logarithms, right? So your first idea is, well, since that's a sum, I can use the product rule. That's true, but remember, when using the product rule, when you're condensing, you have to make sure that those coefficients in front of the logarithms is 1. If not, then you can use the power rule. So in both of those cases, see that? In both of those cases, the coefficient is not a 1. This coefficient is a 7, and this coefficient is a 3. So let's go ahead and use a power rule now. So 7, since that coefficient is a 7, I can write this as an exponent. So it becomes the natural log of x to the 7th power plus the natural log of y to the 3rd power. And now you can write this as a single logarithm. And that's going to be the log of those products. So the product of those arguments will be x to the 7th times y to the 3rd. And that's it. Okay? Number 3. So that's number 3. Okay, number 4. So number 4, you have 3 things. You have 3 logarithms. Don't make it difficult. Always go from left to right. Always go from left to right. So if you need to, cover up some of those terms. So if I look at the first one, remember in order to condense, those coefficients here must be a 1. So I'm going to rewrite this as an exponent. I'm going to rewrite the 5 as an exponent. And while we're at it, let's go ahead and do the 6 as well. So the first thing you need to do is use the power rule. And so this becomes the log base b of x cubed plus the log base b of y to the 5th minus the log base b of z to the 6th power. And now let's go from left to right using our properties. So if I go from left to right, I want you to notice that this is the sum, and notice all the bases are identical. So that's the sum, so I'm going to use the power rule, I'm going to use the product rule first. Okay, so let's do that. So this right here becomes a single logarithm, so it'll be the log base b of x cubed y to the 5th. Okay, and let's go ahead and rewrite this. Minus log base b of z to the 6th. Okay, now finally, we have a subtraction of 2 logs, and the bases are the same. So that means then I'm going to write this as a quotient. So it'll be the log, a single logarithm. So remember, single logarithm. Don't make the mistake. A lot of students do this. they make the mistake and they write this as this, and that's incorrect. They'll say the log of b x cubed y to the 5th divided by the log of b z to the 6th. That's incorrect. Okay? So the difference of two logs is the log of the quotient. One logarithm, not this. That's incorrect. Okay. And the numerator is this first logarithm, the argument, so it'll be x cubed y to the 5th, and the denominator is this argument, so z to the 6th, and that's it. You wrote it as a single logarithm. But notice the process you go through. In every single case, we use just those three properties. Number 5. Number 5 is an easy one. It's not difficult because notice, first of all, the bases are the same, right? And the coefficients are 1s. So this is straightforward a product rule. So as a single logarithm, this becomes a log base 7 of x plus 8 divided by x. And that's it. Nothing more. You're done. Number 6. Well, it's very similar to number 5, right? Except this is the difference of two logarithms. Notice the bases are the same. And this is a 1 right here. This is a 1. So I can write this as a single logarithm using the quotient rule. Subtraction, quotient rule. So that's going to be the log, don't forget, you got to say base 5 now, of x divided by x plus 4. And that's it. All right. Now be careful. In every single case, notice I was very careful to make sure the base was listed. Okay, if you mistakenly leave the base off, so in other words, if you wrote this right here as log of x divided by x plus 4, that's not correct. Because that right here, remember, if there's no base here, that's understood to be base 10. Okay, so be careful. All right, number 7. So number 7, we have, all right, so we have 3 things here. All right, so remember, the first thing you have to do is make sure all those bases are the same. So that's 10, that's 10, that's 10. And the other thing you want to make sure, remember, when condensing, is that those coefficients are all 1s. This one's not. That's a 2 right here. So let's go ahead and rewrite this as an exponent using the power rule. So basically, you're taking n and you're writing it as an exponent. So that's how you get this right here. So then this becomes the log of x minus the log of y squared, so 2 becomes the exponent, plus the log of z. And just like we did in the previous problem, let's go ahead and cover this part up right here, and let's deal with the subtraction. So that's going to be a quotient rule. So as a single logarithm, that's going to be the log of x divided by y squared, right? Okay, now let's write this one over. So plus the log of z. And now I have the sum of two logs. So the sum of two logs is the product. We use a product rule. So this becomes the log, single logarithm of, and I'm going to go ahead and just put in parentheses to help me. So it'll be the first argument times the second argument. So this is what I see. I get x divided by y squared times z. Now, don't leave it like this. I need for you to rewrite this as one fraction. So remember, and let me go ahead and I'll do that right here. So remember, x times y squared, x divided by y squared times z over 1. I multiply the numerator, so that's xz, and I multiply the denominator, so that's y squared. So that is how you want to rewrite this. So the answer is going to be the log of xz divided by y squared. And so there's your answer. And if you want, you can write it like this. Log of, in parentheses, xz divided by y squared. Okay? All right. Number 8. Okay, so let's think about number 8. Number 8 may be a little confusing for some of you. First thing we're going to do, though, is we're going to change this coefficient. We're going to write it as an exponent. So this becomes the log of x to the 5/2 power, just like that, minus, and that's y right here, minus the log of y. Okay, now, remember, and I don't know if I can find it. Maybe, yeah, here it is. Remember a while ago, we talked about this property right here. So we talked about the fact that the b root of x to the 8 power, so I can always write a radical expression as a rational exponent. So the numerator divided by the base. I can always go backwards as well, right? So in other words, I can always change a rational exponent in radical form. So the denominator is your index, and your numerator is your exponent. Okay, so meaning we need to rewrite this right here in radical form. So you're going to say this is going to be, and let me just remind you. So let's do that here. X to the 5/2, using this idea right here, is, remember, the denominator is your index. So that's a 2, you're going to have the square root. It'll be x to the 5th power. So the square root of x to the 5th means 5 divided by 2 as an exponent. All right? And so then this becomes the log of the square root of x to the 5th minus the log of y. And now I'm going to write this as a quotient. Use the quotient rule. So it'll be the log, 1 logarithm, and the numerator will be the square root of x to the 5th, and the denominator will be y. And that's it. So that was number 8. Okay. Number 9, same thing, right? Same thing. So let's go ahead and rewrite this as an exponent, and everything else is 1s. All the bases are 10s. So we're going to get this. So this becomes the log of x to the 9/2 power minus the log of 6y plus the log of z. Okay, now let's go ahead and let's cover this one right here. So we're going to do this first. So that's the sum. I'm sorry, that's the difference. So we're going to use the quotient rule here. So that's going to be the log, or single logarithm, of x to the 9/2 divided by 6y. So that is this, okay? All right, now let's rewrite this. Plus the log of z. Okay, now we're taking the sum of 2 logs now. So if I'm going to condense it, remember condensing means to write as a single logarithm. So we condense this as a single logarithm. Now we're going to condense this as a single logarithm. So that's going to be the log. Since that's a sum, that becomes a product. So let me go ahead and put that in parentheses here. So it'll be the first fraction, the first argument, x to the 9/2 divided by 6y times the second argument. Okay? So the sum of these 2 logs, when condensed, is the log of the product. Now let's go ahead and remind ourselves about this. So let's rewrite x to the 9/2 as radical form. Okay, so let's do that right here. So x to the 9/2 means, remember, the denominator is your index. So it'll be the square root of x to the 9. So that's what this is right here. So I'm going to rewrite this as that. So that's going to be the log of the square root of x to the 9 divided by 6y times z. Okay, now let's look at the argument right here. So the square root of x to the 9th divided by 6y, and that's z divided by 1, right? So I'm going to write this as 1 fraction. So it'll be the square root of x to the 9 times z divided by 6y. So that right here, that 1 fraction goes here. So the answer then will be the log of the square root of x to the 9th times z divided by 6y. And that's it. That's your answer. Okay, now let's look at this one. So this one here, all of these are sums. And again, I need to make sure that I use the product rule, the power rule first, because before I can condense, using the product and the quotient rule, all of those coefficients must be 1s. Okay? In this case, I notice that that's a 6 and that's a 4. So this becomes the natural log of A plus the natural log of B to the 6. So writing the 6 as an exponent, plus the natural log of C to the 4th. Okay? Now, just like we did before, let's go ahead and cover the last one. And let's take care of this one first. So the sum of two logs is the log of a product. Single logarithm. So I'm going to condense this to a single logarithm. So it'll be the natural log of A times B to the 6. A times B to the 6. And then rewrite this over, plus the natural log of C to the 4th. So I have a sum of two logs still, so I can use the product rule. So that becomes the natural log of A times B to the 6. Let me put that in parentheses for a moment. A times B to the 6 times C to the 4th. Well, all these are products, right? So I don't need to put this little symbol right here. So this really becomes the natural log of A, B to the 6, C to the 4th. And that's all it is. And if you think about it, you can always go backwards in your mind. Now there's your answer, but you can always go backwards in your mind and think about, well, if I expand this, I better get this back, right? I better get the original back. And you do, because look, all these are products. So it'll be the natural log of A plus the natural log of B to the 6 plus the natural log of C to the 4th. And that's what this is. And then using the power rule, you then get the original back. And that's all it is. Very simple, isn't it? Okay. Now, let's look at this one. So these are common. Some of these are true, some of these are false. And the false ones tend to be the ones that students have misconceptions about. Just like, if I can find it, just like the one we said earlier. I'm hoping we can get this real quick. Right here. Just like this one. So remember we said earlier, and I forgot what this dealt with, but that was a common misconception that people have with some of these logarithms. Okay, so here's a common misconception that people have with this one. So we have, so true or false, is the log of x plus 3 the same as the log of x plus the log of 3? All right, so what's happening here is that the person that thinks this is equal to this is using the distributive property with logarithm. So they're saying that this is the log of x plus the log of 3. That's not true. So remember, this does not mean multiplication. In fact, if you look at this right here, so this is false. So in fact, though, if you look at this right here, the log of x plus the log of 3, I can use the product rule, right? So according to the product rule, this really is the log of x times 3, which is 3x. So that right here is the log of 3x. Well, the log of 3x is not the same as the log of x plus 3. 3 times x does not mean x plus 3. All right, so that one was false. Let's look at number 2. So the question is the log of 3 times x the same as the log of 3 plus the log of x? Well, that's true, right? So it's true because basically this is a product rule. That's what the product rule says. The product rule says the log of a product is the sum of the individual logs. Let's look at this one. The log of 3y base 3. They're saying is the same as 3 times the log of y base 3. So whoever thinks that thinks this, that I can take that coefficient here and write it as a product. Well, you got to be careful. All right. So remember this right here. Let's think about this. The log 3y base 3 using the product rule really means this. The log of 3 base 3 plus the log of y base 3, right? And notice this is not this. In fact, the log of 3 base 3 is 1. That's 1 right here. 3 to what power is itself? So this is 1 plus a log of y base 3. That's not the same as this. If I look at this, I can think of it this way. 3 log y base 3. So I can use the power rule. I can rewrite this as as an exponent. So it becomes the log of log base 3 of y cubed. And notice that is not what this is not what this is right here. Okay, so that one's false. This one, number 4. So number 4, what someone that says this right here seems to think this, that I can use the power rule here because I see an exponent. And so they think that when you see an exponent, then you can take that exponent, write it out in front. You have to be careful. And by careful, I mean this. That exponent right here is only in relation to the base. Okay? So the only thing being raised to the exponent is that x right here, not that whole thing. It's just the base right here. So if you look at this, if you look at this right here, the exponent is in relation to this whole logarithm, not that base. So if we look at this right here, let's think about this right here. So if we look at 4 log of 3y base 3, and I use the power rule, then 4 is the exponent of 3y. So this becomes the log base 3 of 3y to the 4th. So notice this does not mean the same thing as that. Because if you look at the 4, what's being raised to the 4th power is the log of 3y base 3. What should be raised to the 4th power is only 3y. All right, and so that one's false. Number 5, the log of y to the 4th base 3, is that the same as 4 log of y base 3? Well, since the exponent is only in relation to the base, then according to the power rule, then that means I can write this right here as 4 times the log of y base 3, which is what this is. So that one's true, and that's just using the power rule. Okay. Number 6. So number 6, the question is the log of x divided by 3 the same as the log of x minus the log of 3? The answer is yes, right? That's just using the quotient rule. So that's true using the quotient rule. Let's look at this one. So that's the one here that's the same as this right here. So some students seem to think that when they see this, then that means the log of x divided by the log of y. That's not true. So remember, when we have the log of x divided by 5, the quotient rule says this becomes the log of x minus the log of 5. Well, that is not this. All right, so that's false. Okay, let's look at this one. So the question is the natural log of 1 divided by x equal to negative natural log of x? Well, that is a little bit more difficult to think about, right? So let's first of all use the quotient rule. So by the quotient rule, that means the natural log of 1 minus the natural log of x. Well, the natural log of 1, so remember whenever you're taking the log and the argument's 1, that is always 0. The natural log of 1 is 0. So let me remind you, if I have the log of 1, or the natural log of 1, or the log base 3 of 1, it doesn't matter. All of these is equal to 0. Okay, whenever the argument's 1, whenever you're taking the logarithm of the log of 1, no matter what the base is, it's always going to be 0. And you can easily see that by thinking this. All right, so let's look at this example right here. Log of 1 base 3. Hopefully you'll see that 0. So using the changing this log equation to an exponential, this becomes 3 to the box equal 1. And then 3 to what powers 1? Well, 3 to 0 powers 1. So that's where the 0 comes from. All right? So that becomes 0 minus the natural log of x, and 0 minus the natural log of x is negative natural log of x, which is what this is. So that's true. Now let's look at this one. So this says, true or false, is the log of y to the third base b the same thing as saying the log of y multiplied by itself 3 times? And basically they're saying that since the exponent is 3, then this whole thing means the log of y times itself 3 times, base 3. The answer is false. So remember, you got to be careful. So let me go ahead and write it on here. So remember, the exponent is only the exponent of this base. So then that means that I can use the power rule here. So that becomes 3 times the log of y base 3. And that does not mean this, right? So if I have 4 times 5, does that mean 5 times 5 times 5 times 5 times, oops, sorry. Does that mean 5 times 4 times? No. That's not what that means, right? So that's not what that means. Now, if I had this, I want to show you something. If you had this log base 3 of y all raised to the third power, then that means, so in this case, the exponent is 3, your base is log of y base 3, then that means the log of y base 3 multiplied by itself 3 times. So that is, so this right here would be log of y base 3 raised to the third power. And notice those are not the same. So that one's false. And then finally, let's look at number 10. You have the log of the absolute value of 100x. Don't make that difficult. So let's think about this side right here. So this right here means the log of the absolute value of 100 plus the log of the absolute value of x, right? Well, the absolute value of 100 is 100, right? Because 100 is a number, and I know that the absolute value of 100 is 100. So that becomes the log of 100. Plus, now you got to be careful here. See, you have the absolute value of x. Leave it as the absolute value of x because you don't know whether x is positive or negative here. All right, so leave it as the absolute value of x. So it'll be the log of the absolute value of x. Now, remember the log of 100 I can write, oops, 100 I can write as 10 squared. Well, using the power rule, I can write this as 2 log of 10, right? And the log of 10, remember, is just 1. So that's 2 times 1, which is 2. So then this becomes 2 plus log of the absolute value of x. And that is your answer for this. So the question is this the same as that? And the answer is no. So that's false. Okay? All right, so that is it. So that is a quick review of the properties. If I can find it real quick, sorry about that. That is a quick review of the section dealing with properties of logarithms, where you had to expand or condense, right? So that was a review, where you had to expand log expressions or condense log expressions using these properties. All right, so hopefully this helps.